The screen is visible. Screen is visible. Okay. Module 2, first law of thermodynamics. Module 2, first law of thermodynamics. We are discussing about the first law of thermodynamics. First law of thermodynamics. Thermodynamics for a closed system undergoing a cyclic, or we call it as a Joule paddle wheel experiment. Joule paddle wheel experiment. Through this experiment, we are defining the first law of thermodynamics. Experiment. Joules paddle wheel experiment. We are defining the first law of thermodynamics through the closed system. In a closed system. Now see here. Let us consider a cylinder. This is a cylinder, insulated one. Insulated part, cylinder with an insulated. That means the heat is not dissipated outside the atmosphere. Cylinder, and this is a thermometer which is placed inside the cylinder for measuring the temperature. Thermometer, which contain a scale over the periphery. This is the liquid, considered as a water or gas. Having a mechanism at the bottom, this part we call as a pedal, fan-like structure. Above here there is a pulley arrangement through which the weight moves up and down. The dead weight moves up and down. W weight moves up and down. This is a pulley arrangement. This is a stirrer. Water, cylinder with an insulated cylinder which is insulated. Let us consider a XY graph in order to understand the path. x, y. From 1 to 2, 1 to 2 and 2 to 1. From 1 to 2, delta W. From 2 to 1, from 2 to 1, delta Q, delta Q. Delta, either you can go for delta, represent delta in this way, or delta in this way, similar to the curve. Now, the Joule is a scientist who has conducted an experiment in order to define the first law of thermodynamics. He has conducted this experiment in 1847. Between these 7 years, he has conducted an experiment in order to define the first law of thermodynamics. He has considered a cylinder, insulated part. Cylinder is insulated, and he has placed a thermometer and a mechanical arrangement in order to alter the temperature. What he does, it is completely insulated. A water is placed inside. A thermometer is placed here. First, he will consider a temperature T1. He will note down the temperature T1, maybe 20 degree or 30 degree, whatever the inside temperature is, he will note it down. Next, he will conduct an experiment, but through the pulley arrangement by means of a weight. See here, as the weight moves downward, the pulley will move. In turn, the pedal will rotate. Which in turn the steering mechanism will occur. As a result, there is a temperature difference occur. First, the temperature may be 20 degree. Because of the work done, because of rotation of this pedal, maybe the temperature is to 40 degree Celsius. At the initial 10 or 20 degree, because of the movement of the weight, which in turn rotate the pedal through the pulley, and which in turn it alters the temperature. Then he has considered that from the process 1 to 2, the work is here into the system. This is nothing but a system. This is a system. From 1 to 2 process, the work is done. Therefore, we call it as a delta W. How the work is occurs? Because of the movement of the weight towards downward, which in turn the rope is connected to the pulley and to the steerer, which will rotate. As a result, the temperature differences occur. At the beginning, the temperature is 20 degree. Because of the rotation of the fan, the temperature may occur at 40 degree. We will call the first temperature T1 and second temperature is T2. Next, what he does, through the XY graph, he will draw a path from 1 to 2, the work is done. This is the 1 to 2, the work is done. Next, what he does, he removes the insulation. As it removes the insulation, then what happens? The heat will be dissipated into that of the. As the insulation is removed, the heat is dissipated into that of the atmosphere. Then it reaches to the thermal equilibrium. That means from 2 to 1, after removing the insulation, what happened? Without insulation, the container comes directly contact with the atmosphere, which in turn the heat is dissipated into the atmosphere. As it dissipated into the atmosphere, it will bring back to that of the thermal equilibrium state. The dissipation is carried out from 2 to 1. We are represented by delta Q. It is represented by delta Q. Therefore, he has concluded that the Joule has concluded that delta W is proportional to delta Q. The work done is directly proportional to heat. That means heat transfer. Work done is directly proportional to heat transfer. Next, he has given that integration of delta W is equal to the integration of delta Q. Integration of delta W is equal to the integration of delta Q, proportional limit. In order to remove the proportionality limit, they have introduced a Joule, a constant we call as a Joule, J. Integration of delta W. The value of J will be 1, always 1 Newton meter per joule, always 1. Therefore, if you substitute the 1 in place of J, the integration of delta W is always equal to the integration of delta Q. Then he has given one statement that the first law states that for a closed system undergoing a cycle, the cyclic integral of work is equal to the cyclic integral of heat. This is the statement given by the Joules. This is we call as a first law of thermodynamics. They integrated, the symbol integrated indicate the cyclic integral of, or integration over the entire cycle, or integration over the entire cycle. This is about the first law of thermodynamics. Any doubt regarding the first law of thermodynamics? ಏನಾದರೂ ಡೌಟ್ ಇದ್ದರೆ ಹೇಳ್ರಪ್ಪ ಫಸ್ಟ್ ಲಾ ಆಫ್ ಥರ್ಮೋಡೈನಮಿಕ್ಸ್. See here, the first law of thermodynamics is nothing but integration of work is equal to integration of heat, or integration of work is equal to integration of heat transfer, or sum of the work is equal to sum of the heat. Sum of the work is equal to sum of the heat. We can sometimes we also called as summation of delta W is equal to summation of delta Q, also can be written there. Or some book they will refer as summation of W is equal to summation of Q. The Joule has conducted an experiment in 1940 to 1947 in order to define the first law of thermodynamics. He has taken a cylinder and it is insulated maybe through the cotton or to the other material, so that the heat should be dissipated outside the atmosphere. See here, he has considered in a closed system, not a open system. In a closed system, what happened? The mass remains same. In the closed system, the mass remains. That means the whatever the quantity of water is there, 1 kg of water, it remains same. It doesn't change. We call it a closed system. Now see here, in a closed system, he has considered a cylinder. Around that cylinder, insulator is placed. Material, maybe a cotton is placed in order to avoid the heat dissipating into that of the atmosphere. Then he has inserted a thermometer in order to measure the temperature, and a mechanical arrangement such as weight and pulley arrangement is done. Through a rope. Now he has first, during the process 1 and 2, the temperature is taken out. That means T, temperature is taken. Next, at that time what happened? temperature, after taking the temperature, the weight is dropped from certain height. As the weight drops, the stirrer will rotate. The stirrer will rotate, which in turn it rotates the pedal through the pulley arrangement, which in turn the movement of the molecules occur inside water and the temperature T2 reaches, and which is shown into the thermometer. That means from 1 to 2 the work is done, we call it as delta W. 1 to 2 the work is done, we call it as delta W. Next what he does, he removes the insulators from the cylinder. After removing the insulators, what happened, whatever the heat is there, T2, it will drop. The heat is dissipated into the atmosphere till it becomes equilibrium temperature. Whatever the equilibrium temperature is there, it reaches same. Now see here, from 2 to 1 the heat is dissipated into the atmosphere. That means the insulator is removed, the heat is dissipated into the atmosphere till it reaches the thermal equilibrium. Therefore he has concluded that the work is proportional to heat transfer, or work is proportional to heat. Further, integration is proportional to the delta W is proportional to the integration of delta W. Integration indicate it is a cycle. It is a cycle, 1 to 2, 2 to 1. It is a cyclic process. It is a cycle. It is a cyclic process. If it non-cyclic means it should be an irregular shape. Non-cyclic means it should be an irregular shape, we call it a non-cyclic process, which doesn't follow any path. The heat enters and heat leaves, we call it the heat enters and heat leaves without any proper path, we call it a non-cyclic path. In cyclic path, a proper path has to be followed. Now, they have introduced a constant called J, which is equal to 1. In order to remove the 1 J value, we have to substitute 1 here. Therefore, he has concluded that the cyclic integral of the work is equal to the cyclic integral of heat, or heat transfer. This is the statement for first law of thermodynamics. First law says that heat is proportional to work, or work is proportional to heat. This is the first law of thermodynamics. Any doubt regarding the first law of thermodynamics? Any doubt idea? ಓಕೆ, ಅರ್ಥ ಆಗಿದೆಯಲ್ಲ? समझ में आ गया?
Yes, sir. Yes, sir.
ओके.
ಅದು ಇಂಟಿಗ್ರೇಷನ್ ಸತ್ತರನ್ನು ಬರಿಬಹುದು ಸರ್.
ಹಾ, ಬರಿಬಹುದು. ಇಂಟಿಗ್ರೇಷನ್ ಈ ತರ ಇಂಟಿಗ್ರೇಷನ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಆರ್ ತುಂಬ ಬುಕ್ ಒಳಗೆ ಸಮೇಷನ್ ಅಂತಾನು ಕೊಟ್ಟಿದ್ದಾನೆ. ಸಮೇಷನ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಡೆಲ್ಟಾ ಡಬ್ಲ್ಯೂ ಇಸ್ ಈಕ್ವಲ್ ಟು ಸಮೇಷನ್ ಆಫ್ ಡೆಲ್ಟಾ ಕ್ಯೂ, ಆರ್ ಈ ಥರ ಸಮೇಷನ್ ಆಫ್ ಡಬ್ಲ್ಯೂ ಇಸ್ ಈಕ್ವಲ್ ಟು ಸಮೇಷನ್ ಆಫ್ ಕ್ಯೂ ಅಂತ ಕೊಟ್ಟಿದ್ದಾನೆ. ಓಕೆನಾ?
ಓಕೆ.
ನೌ ಫಸ್ಟ್ ಲಾ, the first law of thermodynamics for change in state of a closed system. Sometime in exam they will ask as a proof that internal energy is a property of system. Internal energy is a property of system. First law of thermodynamics for the change in state of closed system proves that internal energy is a property of system. Internal energy is a property of system. let us consider a PV diagram, pressure and volume diagram, followed by a cycle 1 to 2, 1, 2, P is the path, from 2 to 1, consider this is R, one more, 1 to 2, consider as yes. We need to prove that internal energy is a property of system. If you go from the top equal to that of the 2 to 1, if with respect to R and S, it should remain same, and internal energy should be remain same here. We have to prove that internal energy is a property of system. Now see here, from the first law, or consider a system that undergoes a cycle changing from state 1 to state 2 by the process P, and returning to state 1 by the process R, shown in the figure. Consider a system which undergoes a cyclic changing from state 1 to state 2. State 1 and state 2, these are the state 1 and state 2, by the process P, and returning to the state by it straight to the R. Now that means we are considering P and R here by applying the first law of thermodynamics. From first law of thermodynamics, by the first law of thermodynamics, what does the first law of thermodynamics says? ಯಾರಾದರೂ ಹೇಳ್ಬೋದಾ ಫಸ್ಟ್ ಲಾ ಆಫ್ ಥರ್ಮೋಡೈನಮಿಕ್ಸ್ ಏನಂತ ಹೇಳುತ್ತೆ? ಫಸ್ಟ್ ಲಾ ಆಫ್ ಥರ್ಮೋಡೈನಮಿಕ್ಸ್ ಕ್ಯಾ ಬೋಲಾ बोलिए. ಫಸ್ಟ್ ಲಾ ಆಫ್ ಥರ್ಮೋಡೈನಮಿಕ್ಸ್ ಏನಂತೆ? ಇಂಟಿಗ್ರೇಷನ್ ಆಫ್ delta Q is equal to integration of delta W. Integration of work is equal to integration of Q, or integration of Q is equal to the integration of work. This is the first law of thermodynamics. Now consider two separate processes we have. Now go for integration 1p 2p 1p to 2p delta Q plus integrations here 1p, we are moving from 1p 2p. Next, considering the two state process from 2 to 1, that means 2r 1r delta Q is equal to integration of 1p 2p delta W plus integration of 2r 1r delta W. Any doubt in this part? We are considering two process from P and R. The heat is added and the work is added. Work input occur, heat rejection occurs. ಓಕೆನಾ? ಏನಾದ್ರು ಡೌಟ್ ಈ ಪ್ರೋಸೆಸ್ ಒಳಗೆ ಇಲ್ಲಿ ಗೊತ್ತಾಗಿದೆಯಾ?
ಆರ್ ಅಂದ್ರೆ ಏನು ಸರ್?
Just line. It is a path. ಈಗ P is nothing but is a naming is given from the state 1 and 2. It is a notation P. From 2 to 1 it is a notation R. Next from 2 to 1 one more path S. If I follow the path 1 and 2, what happen? We are going to see. If I follow the path 2 to 1 with respect to R, what happens? We are going to see. If the third path is added, then what happens? We are going to see. Whether the heat and work is going to alter or not, we are going to see here in terms of internal energy. ಅಂದರೆ ನಾವು 1 to 2 ಪಾತ್ ಫಾಲೋ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ, 2 to R ಇಂದ ಫಾಲೋ ಮಾಡಿದ್ರೆ ಏನಾಗ್ಬೋದು, ಅದೇ ನಾನು ಕಾಂಬಿನೇಷನ್ ಆಫ್ ಪಿ ಮತ್ತು ಎಸ್ ಫಾಲೋ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ ಅಂತ ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ, ಥ್ರೂ ದ ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಡಿಸ್ಕಸ್ ಹಿಯರ್. These are the just notation. These are the notation. ಒಂದು ನಿಮಿಷ. Next here, now consider cycle, other cycle, the system changing from state 1 and 2 by the process P and returning to state 1 by the process yes for this cycle we can write now see here, in the first process we have taken P and R. In the next process we are going to select the combination of P and S. In the first P and R, in this process we are considering P and S. Then what happened, we are going to see it. See here, similarly applying the first law of thermodynamics, integration 1 to P 2P 1P 2P delta Q plus integration, now we are moving from the S, here we have moved from the R, now we are moving from the S, from 2S 1S delta Q is equal to integration of 1P 2P, we have to write delta W, plus we are moving from the S, 2S 1S 2S from 1S delta W. Consider this is equation 1, equation 2. Any doubt? First we have considered two processes P and S, P and R. In the next we are considering P and S. Either you can consider R and S, one and same. This is nothing but 2 and 1. We have obtained 2 and 1 equation. Now subtracting 1 and 2. Subtracting 1 and 2. Now here we have to subtract 1 and 2, then what happened? First I will consider this one, integration 1P 2P delta Q plus integration 2R 1R delta Q minus I will consider this part, integration 1P 2P delta Q minus, because we are multiplying with the minus here, subtracting here, we need to subtract, this become minus, this plus becomes minus, integration 2S 1S delta Q Similarly, first one, integration 1p 2p delta w plus 2r 1r delta w minus, we have to minus it, minus 1p 2p delta w, because we are subtracting it, this plus becomes minus, minus 2s 1s delta, we are subtracting it. Now here what happens, 1p 2p delta w minus integration of 1p 2p delta w get cancelled, it cancels. Similarly, here 1p 2p work done get cancels, get cancels. Further integration of 2r 1r delta w minus integration of 2s 1s delta w is equal to integration of 2r 1r delta w minus integration of 2s 1s delta w. Bring w this direction, integration of 2 1r delta w, it becomes minus integration of 2r 1r delta w. Bring this s term this direction, integration, next term become positive, integration of 2s 1s delta w, sorry delta q minus integration of 2s 1s delta w. We can write the above equation in this form by taking its common 2r 1r delta q minus delta w is equal to integration of 2s 1s delta q minus delta w minus delta w. That means if you consider any path from P2 or R or S, the solution remains same. Delta Q minus delta W is equal to integration of delta Q minus delta W. It remains same. Further, we are going to consider only this part. That means delta W minus delta Q minus delta W, we are going to consider dE value. We consider dE value or consider delta E value, no problem. Delta E value. Now what is delta E? Delta E referred as internal energy. We referred as internal energy here. Delta E we referred as a internal energy. That means this is a process, the work is done, some work is occurring here. Because of work, the heat is dissipating. Now, in between what internal energy occurs? Internal energy, it may be a kinetic energy, potential energy or chemical energy, or movement of molecules occurs. That is noted by delta E. Now, as per the experiment, what happened? He has concluded that the heat is proportional to work, or work is proportional to heat. He has concluded that. With the further explanation, we are going to obtain the internal energy change. There is an internal energy change also occurs. Because of this, heat adding and heat rejection. Heat adding and heat rejection. Now let us take an example of a IC engine. The work output is nothing but movement occurs. But inside the cylinder the chemical reaction occurs, which in turn the movement of the vehicle occurs. Here we are going to find out the internal energy. That's called as the internal energy. He has discussed first one. With respect to first law, heat is proportional to work. If the heat is proportional to work, inside the some internal energy has to be change occurs. That internal energy we call as a delta E. Delta W is nothing but delta E. And further we can write as, can be written as integration of 2R 1R delta E is equal to integration of 2S 1S delta E, or we can also write as delta E is equal to delta E. That means if you move the path from 1 to 2 or from the R or P or S, the internal energy remains same, doesn't affect. The internal energy remains same, it doesn't affect. Further, see here, further delta E internal energy delta E, which is a combination of internal energy plus kinetic energy plus potential energy. Delta E further we consider as internal energy, we are referring as delta U. Internal energy we refer to delta U, because inside there is maybe chemical reaction occurs, or the movement of the molecules occurs, and the kinetic energy may occur. The motion will occur, or the potential energy, we call it the stored energy, may occur. We call as a delta KE plus delta P, delta KE or delta PE. Since energy is a property internal energy U is also a property of system. That means we are considering internal energy is a property of a system. Now just assume it, if you neglect kinetic energy and potential energy, neglecting kinetic delta W and delta PE, then what happens? We can write as delta E is equal to delta U. Delta U is nothing but the internal energy, we referred as a internal energy. Here delta E referred as a energy. It is referred as a energy. This energy consisting of combination of internal energy, kinetic energy, potential energy, or chemical energy, or movement of the molecules. It is nothing but a combination combination. Internal energy we are referring as a delta U. Internal energy,
ಡೆಲ್ಟಾ ಯು ಅಂದ್ರೆ ಏನ್ ಬರುತ್ತೆ?
delta U is nothing but we are considering internal energy. Internal energy.
ಹಾ.
It is a normal energy.
ಡೆಲ್ಟಾ ಇ ಆಲ್ಸೋ delta E is normal energy. Delta U is internal energy.
Delta E is nothing but energy which contain internal energy, kinetic energy, potential energy, chemical energy, movement of the molecules. We call as a delta E.
Okay.
Now
okay,
particularly we call as a internal energy du. Sorry, delta U we call as a internal energy.
Okay.
Internal energy. This is internal energy. Kinetic energy. For example, let us consider a human body. We have energy. Kinetic energy is nothing but the movement of the body occurs. Plus the potential energy. For potential energy which is stored inside the body. Internal energy ಇದ್ದೇ ಇರುತ್ತೆ. ನಾವು ಮೂವ್ಮೆಂಟ್ ಮಾಡಲಿಕ್ಕೆ kinetic energy ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಅಂದರೆ ಮೂವ್ ಮಾಡ್ತಾ ಇದ್ದರೆ kinetic energy. Potential energy is nothing but stored energy. Potential energy is nothing but stored. If you are neglecting kinetic and potential energy, then we call as a delta E is nothing but delta U. Delta E is nothing but delta U. Let us consider this is a equation A. Let us consider this is equation A. Now substituting in equation A, substituting this value B, substituting equation B in A, then what happened? Delta Q minus delta W is delta U. Further it can be written as delta Q is equal to delta U plus delta W. This is the one more law, first thermodynamics law with respect to internal energy. Delta Q is equal to internal energy plus work done. Internal energy plus work done. ಇದು ಒಂದು ಇಂಪಾರ್ಟೆಂಟ್ ಈಕ್ವೇಷನ್. ಮ್ಯಾಕ್ಸಿಮಮ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಈ ಈಕ್ವೇಷನ್ ಮೇಲೇ ಬರುತ್ತೆ. ಅರ್ಥ ಆಗಿದೆಯಾ? ಅರ್ಥ ಆಗಿದೆಯೇನ್ರಪ್ಪ?
Yes sir.
Here we are neglecting the potential and kinetic energy. Now further, this is the important equation. Equation ಮೇಲೇನೆ
ಸರ್ ಈಕ್ವೇಷನ್ ಅಲ್ಲಿ Q ಅಂದ್ರೆ ಏನು ಸರ್? Q ಬಂದು
Q heat, internal energy, work. Heat is there, internal energy is there, work is there.
Okay sir.
Okay na? Here we are neglecting the kinetic and potential energy. By neglecting, this equation will arise, which plays an important role for solving the n number of problems. Now what is potential energy?
Sir.
ಹೇಳ್ಬೇಕು
ಸರ್, ಇಂಟರ್ನಲ್ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಮತ್ತೆ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ
ನೆಗ್ಲೆಕ್ಟ್ ಮಾಡಿದ್ದೀವಿ. ಅದು ಹೇಳ್ತೀನಿ ಈಗ ನೆಗ್ಲೆಕ್ಟ್ ಯಾಕೆ ಮಾಡಿದ್ದೀನಿ ಅಂತ ಹೇಳ್ತೀನಿ. ನೆಗ್ಲೆಕ್ಟ್ ಮಾಡಿದ್ದು, ವಾಟ್ ಇಸ್ ದ ರೀಸನ್ ಫಾರ್ ನೆಗ್ಲೆಕ್ಟಿಂಗ್, ಐ ವಿಲ್ ಟೆಲ್ ಯು. ನಾವು ಸಿ ಹಿಯರ್ ದ potential energy, see here, potential energy, the PE, we know that the potential energy formula mg into Tz or delta Z, mg into delta Z. Now potential energy, what is meant by potential energy? See here, let us consider a component which having inlet and outlet. This is the datum line. This is the datum line. This is the Z1 and Z2, because delta Z we are referring as a Z1 and Z2. ಇಲ್ಲಿಂದ ನೀರು ಹಾಕಿದ್ರೆ ಇಲ್ಲಿ ನೀರು ಬರುತ್ತಾ? ನೋಡ್ಕೊರಿ, if I pour a liquid here, does the liquid reaches here? Because here Z1 is equal to Z2. Z1 is equal to Z2. Potential energy works if there is a difference in height. Potential energy works if there is a difference in height. Similar to the, if there is a difference in height, the potential energy will exist. Otherwise, the potential energy will be zero. For example, a dam is constructed from the penstock to the nozzle. The water is from the dam. Idu one dam irutte. This is the dam. Here the potential energy is stored. Here the potential energy is stored. This is nothing but height Z1 and this is Z2. The water stores the potential energy. When it moves downward, it converts into kinetic energy. If there is a difference in head, then what happened? Height, then only we can extract the energy. If the height remains same, then what happened? The potential energy becomes zero. Potential energy becomes zero. Therefore, we are neglecting here. Neglect ಮಾಡ್ತೀವಿ. ಅರ್ಥ ಆಗಿದೆಯಾ potential energy? Potential energy works if there is a difference in height. Then only the potential energy works. Otherwise, the potential energy becomes zero. This is the condition. Z1 and Z2 become zero. M, what is M? This is the mass. Mass is into gravity. Z is nothing but difference in head or difference in height. We call it as a head. This is the general formula for potential energy. The potential energy formula mg into z anta ಕರಿತೀವಿ. Here delta z is given because z1 and z2 we are referring as a delta z or dz. Dz or delta z. It is nothing but z1 and z2. Difference in height. Now, similarly, if you go kinetic energy, if you go for a kinetic energy, delta Ke referred as 1 V bar square divided by 2. That means 1 by 2 m V square. This is the kinetic energy formula, general formula. Potential energy Pe is equal to mg z. Z is nothing but in height. This is the potential energy formula. This is kinetic energy formula. In terms of thermodynamics, we are taking as V bar square divided by 2. We are taking in terms of V bar square divided by 2 because we are referring V value for volume. For volume, we are considering a small v. For velocity, we are considering a bar. Volume ಗೆ v ಅಂತ ತೋತೀನಿ, velocity ಗೆ bar ಅಂತ ತೋತಾ ಇದ್ದೀನಿ. Because the volume plays an important role. Volume ಬರುತ್ತೆ further ಒಳಗೆ. Therefore, volume we are considering a small v. For capital V bar, we are referring as a velocity. Or just draw a bar above, we call as a velocity here. This is the kinetic velocity. If there is a difference in height will be zero, then what happen? Kinetic energy will be what? ಈಗ difference in height zero ಇದ್ರೆ ಏನಾಗುತ್ತೆ kinetic energy? ಈಗ height ನಿಮ್ದು ಏನೂ ಇಲ್ಲ ಅಂದ್ರೆ kinetic energy ಏನಾಗುತ್ತೆ? ಅಷ್ಟೇ, ಝೀರೋ ಆಗೋಕ್ಕೆ ಅದಕ್ಕೆ ನಾವು ನಾರ್ಮಲಿ ವಿ ಆರ್ ನೆಗ್ಲೆಕ್ಟಿಂಗ್ ಅಂತ ಹೇಳ್ತೀವಿ.
ಓಕೆ.
ಸರ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಫಾರ್ಮುಲಾ ಹೇಳಿ ಸರ್.
kinetic energy ನಾರ್ಮಲ್ kinetic energy ಫಾರ್ಮುಲಾ 1/2 mv ಸ್ಕ್ವೇರ್ ಅಂತ ಬರುತ್ತೆ. kinetic energy ಫಾರ್ಮುಲಾ potential energy ಫಾರ್ಮುಲಾ mg z.
ಅಷ್ಟು ಬರ್ದ್ರಲ್ಲ m v ಮೇಲೆ
ಬಾರ್ ಸ್ಕ್ವೇರ್ ಸೇಮ್ ಇದೇ ಥರ ಬರುತ್ತೆ. ಈಗ ಇದೇ ನಾನು ಎಮ್ ವಿ ಸ್ಕ್ವೇರ್ ಡಿವೈಡ್ ಬೈ 2 ಅಂತ ತೋತೀನಿ. ಇಲ್ಲಿ ಬಾರ್ ಯಾಕೆ ತೋತಾ ಇದ್ದೀನಿ ಅಂದರೆ ವಿ ಆರ್ ರಿಪ್ರೆಸೆಂಟಿಂಗ್ ನಾರ್ಮಲ್ ವಿ ಆಸ್ ಎ ವಾಲ್ಯೂಮ್ ತೋತೀನಿ ನಾನು. For velocity, we are referring as a bar. Velocity, we are referring as a bar. For velocity, we are referring as a bar. ನಮ್ಮ ನೆಕ್ಸ್ಟ್ ಫಾರ್ಮುಲಾಸ್ ಒಳಗೆ ಈ ಥರ ಎರಡು ವಿ ಬರ್ತಾ ಇರುತ್ತೆ. ಆ ಕನ್ಫ್ಯೂಸ್ ಆಗಬೇಡ ಅಂತ ನಾವು ಬಾರ್ ಹಾಕ್ತಾ ಇದ್ದೀವಿ ವೆಲಾಸಿಟಿಗೆ. ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ? ಸಾಲ್ವ್ ಮಾಡೋ ಟೈಮಿಗೆ ವೆಲಾಸಿಟಿ ಅಂತ ಬರೆದ್ರೆ ವಿ ಹ್ಯಾವ್ ಟು ಗೋ ಫಾರ್ ಬಾರ್. ವಾಲ್ಯೂಮ್ ವಿ ಹ್ಯಾವ್ ಟು ಟೇಕ್ ವಿ. ವಾಲ್ಯೂಮ್ ವಿ ಹ್ಯಾವ್ ಟು ಟೇಕ್ ವಿ. ಓಕೆನಾ?
Okay, sir.
Okay. Okay. Now see here. From the first law, we have arrived an equation delta Q is equal to delta U plus delta work W. We arrived an equation here. Through this one, we can find out the internal energy. How? See, delta Q, delta U we referred as internal energy at the exit, internal energy at inlet, plus we are considering a potential energy now. Kinetic energy, we are considering a kinetic energy m v2 bar square divided by 2 plus mg z2 minus z1 plus delta w. Now see here, this equation we call as a steady state equation. Equation ಹೆಂಗೆ ಬಂದಿರಬಹುದು ಹೇಳ್ರಿ? This equation arrives if there is a difference in height. If the difference in height, we have to write in this way. Z1 is there, Z2 is there. Here U1 will be there, here U2 will be there. Here U1 will be there, internal energy at the inlet, internal energy at the exit. Next, internal energy at kinetic energy at inlet, kinetic energy at outlet, velocity. We are referring as a velocity. Z is nothing but potential energy. Now it is written in this complete form. Regarding this formula, ಏನಾದರೂ ಡೌಟ್ ಇದ್ರೆ ಹೇಳ್ರಪ್ಪ. ಏನಾದರೂ ಡೌಟ್ ರಿಗಾರ್ಡಿಂಗ್ ದಿಸ್ ಫಾರ್ಮುಲಾ?
ನೋ ಸರ್.
ಇದು ಯಾಕೆ U1 U2 ತೊಗೊಂಡಿದ್ದೀನಿ ಹೇಳ್ರಿ ಯಾರಾದರೂ? Why I have considered U1 and U2? U1 U2 V2 V1 Z2 Z1. Why I have taken this one? Because of
ವರ್ಕ್ ಡನ್ ಆಗಿದೆ. kinetic energy
see here, because the difference in Z1 and Z2, because of Z1 and Z2 there is a tilt. As a result, what happened, we have to consider internal energy at the inlet, velocity at the inlet, or pressure at the inlet. We have to consider pressure, velocity, energy, volume at inlet, and exit P2, U2, V and Z, because of the differences because of differences because of something. Okay na?
Okay sir.
Because of differences. Not getting it. Can you repeat it?
Sir, is Z2 with upside, sir? Because Z2 minus Z1, Z2 will be supposed to be height more.
Z1 and Z2 you are telling about this one. As we solve the problem, we will get more clear here. Okay? Now here this part we call as the internal energy. This is nothing but internal energy. Internal energy. For your exam, only this part is enough. Up to this part is enough. Up to this part is enough. Up to this part is enough. For the exam, this part is enough. Okay, अर्थ ಆಗಿದೆಯಾ? समझ में आ गया?
Yes, sir.
Okay.
ಸರ್ ಎಕ್ಸಾಮ್ಗೆ
हाँ
ಕೆನೆಟಿಕ್ ಎನರ್ಜಿ ಮತ್ತೆ ಝೆಡ್
ಬೇಕಾಗಿಲ್ಲ.
ಬರಲ್ವಾ?
ಬರಲ್ಲ ಮಾತ್ರ. ಹಾಂ ಅದು ಪ್ರಾಬ್ಲಮ್ಸ್ ಯೂಸ್ ಆಗುತ್ತೆ.
ಹಾಂ ಓಕೆ ಸರ್.
ಅದು ಅಷ್ಟು ಇಂಪಾರ್ಟೆಂಟ್ ಬರಲ್ಲ, ಓನ್ಲಿ ಪ್ರಾಬ್ಲಮ್ಸಿಗೆ ಯೂಸ್ ಆಗುತ್ತೆ. ಇದು ಮಾತ್ರ ಇಂಪಾರ್ಟೆಂಟ್.
ಓಕೆ ಓಕೆ
ಓಕೆ ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು ವೆರಿ ಮಚ್.
ಥ್ಯಾಂಕ್ ಯು.
Thank you, sir.
Thank you, sir.
Right.
Thank you, sir.